So, hi connections. This is Atish Lingam, and I am welcome you all to the seventh episode of AI Things Season One. So, I think this is the first time in AI Things history. Either I have not started a long journey. I am just started the season one. I think hereafter there will be season two, season three. I don't think that really. If it comes, I I won't think that I am sitting in the same place and I am recording three sessions for you people, three episodes probably. I think that won't happen. This is the first time, and this is the first season. I think that would happen because I need to give you people the season one. So it's already so much delayed. If you notice the date uh, where I started the episode one, it is pretty much a lot delayed, I think. So I was going harder. So I think season 8 will be the finale episode, and I am keeping all the interesting steps from 7 to 8. So because from the last episode, have run out of time, so I am continuing the part here. So that's the thing, right? We should not rush up things because we said in the next episode I am giving you all these interesting stuff, and that would be the final episode. So we should not rush up things like that. So I thought I gonna keep another episode and I gonna discuss few things in that episode, and probably the next episode we can tell our connections that that would be the final episode. So I am coming straight away to the episode 7. That's the concept. So yeah, episode 7, and here we're gonna discuss again the multiple linear regression from the point where we left. So jumping into that. So I'm going there. Yeah. So yeah. So yeah, as I said earlier, the independent variables that is nothing but input columns. So here the charges is the output column. So we kept in the dependent variable. So independent variable contains 1, 2, 3, 4, and 5 columns. That is nothing but 1, 2, 3, 4, and 5 up to the smoker, yes or no. And we are taking this charges as a output column. So after that, we are just displaying our input without that's the output column. So we have the 5 columns and our output variable as well. That is nothing but the charges. That is the output column. So here we are importing the train test split up, and we are passing our input and output variable, and we are splitting our training and test set. That is nothing but I already said that 1 by third will be given to the test set, and 2 by third will be taken to the training set. This random state is nothing but our model will be randomly shuffled. That's the correct word, I think. So see here, we can see the index of 482 and 383, 38 and 356. It is randomly shuffled. So we have 592 rows. This is nothing but training set, and we can view the test set as well. We have 446 rows. That is the 1 by third, and 892 rows. That is nothing but 2 by third. So you can pretty easily have a mindset of what I am saying. So here we are calling from sklearn linear model. We are importing linear regression as well. So multiple linear regression is nothing but we have multiple columns. That is why it is named as multiple linear regression. uh, Simple linear is nothing but we have only one input column and one output column. Here we have five input columns and one output column. That is why it's named multiple. So the same which I thought in the simple linear regression. So here wait. So as I said earlier, how much input columns are there, so that much weights will be generated. So 260 is the one weight for one column, which is age, and for BMI 315 for children. So it is nothing but that is kind of done with a model, so you don't want to get feared. And bias is nothing but we have only one value for that, that is minus 12013.760 and something. So that is the formula. In the simple linear regression, I have showed you the formula. I have written down, so we can create in your mind of think how this formula will be worked out. So yeah, so we are predicting our test set with the regressor, which we have fitted our x train and y train values. So if we predict the test set with that, we contain a we get an output of a lot of values. So the next step is scoring it and calculating the accuracy of our model performance. So from metrics we are importing the R score, and we are just passing the actual values, that is nothing but y test, that is nothing but test set values and predicted values of the same y train. So we have the actual values in the y test and the predicted values in the y predict. So if we run that and we execute the variable r2 value, we get 0.7865, that is nothing but 78.65 percentage of accuracy. So that's pretty average accuracy in terms of AI. Not bad, but an average. If it is nearly 80, so it is pretty good as well. So we have a lot of models, and we can run this in a lot of models in the upcoming episode. I'm gonna reveal one by one. So if in which model gives you the best accuracy, you can take that to the deployment, and you can do the prediction with that algorithm, the model. So here we are doing the prediction. So we are passing some values, 1833.770110, that is nothing but the format of this age, BMI, children, and sex and smoker, yes or no. If we pass that, we can get a result of 3787.88, that is nothing but the insurance charges we have predicted for the person. So this is how our algorithm works, and so that's what I came here to say. And I think this is enough for the regression, and I'm done with the season one. And in the next episode, there are a lot of interesting stuffs that I said earlier. So thank you guys, and let's catch you all in the next episode. Don't forget to watch that, and you people will really get interested with the season. So the final episode will be a fire. So bye guys.